Hello beautiful people, my name is Peter. Welcome to my YouTube tutorial. In this section I'm going to be discussing General Biology 1, and our topic today is going to be the organic molecules. So under organic molecules we have a bunch of compounds that are proteins, carbohydrates, lipids, and then nucleic acids. Then we shall also look at what we call monomers, isomers, functional groups, and then hydration and dehydration reactions. So therefore to begin with, an organic molecule is a component that has carbon as its basic molecule or element, and with a bunch of other elements that we are going to see, so which include carbon, hydrogen, oxygen, phosphorus, and nitrogen. So these are the basic elements that we are going to look at within these molecules. So they all have at least one or two or three of these elements, with carbon inclusive. So therefore, to begin with the elements in a protein. So in a protein we have carbon, we have hydrogen, we have oxygen, and we have nitrogen. So with carbohydrates we have carbon, hydrogen, and oxygen. And lipids we have carbon, hydrogen, and oxygen. Whereas the nucleic acids have carbon, hydrogen, oxygen, nitrogen, and phosphorus. So nucleic acids have more elements than the other three macromolecules. Then we are going to look at what we call the functional group. So a functional group is a group of atoms, or an atom that takes part in the chemical reaction. So the functional group of proteins, functional group. Okay, before I do the functional group, let me write here the monomers. Then I do the functional group last. So a monomer is the basic unit of a given macromolecule. Like for example, the monomers of proteins are amino acids. The monomers of carbohydrates, we generalize and say they are sugars, or saccharides, monosaccharides. Then for lipids, we have 3 fatty acids and glycerol. And then lastly, nucleic acids, we have a bunch of elements here. We have the ribose sugar, ribose. We also have the phosphate, and also a nitrogen base. So to look at the functional group of proteins, so we have amino acids as their monomers. So amino acids have 2 functional groups. We have what we call the carboxylic group, COOH, and also an amino group, which is NH2. So this is nitrogen and carbon and hydrogen and oxygen. So this is the functional group of a protein, or an amino acid. Then the functional group of sugars, we have 2 of them. We have what we call an aldehyde and also a ketone. So these are the two types of functional groups in a sugar. Then for the lipids, we have what we call an ester. So with this, I will just only represent it in this form. I'll elaborate this more as we go on in the chapter. So then lastly, the functional group of nucleic acids, we have a sugar, a ribose sugar is an aldehyde, or it can be a ketone. So we see this has a bunch of these. So a ketone, or a phosphorus, a phosphate. Then a nitrogen base. So nitrogen bases, we have the pyridines and the purines. So all these have nitrogen as their basic functional group. So we've seen the monomers of the macromolecules. We've seen let's discuss the an isomer. So an isomer, the word iso means same. So an isomer is a group of atoms or an element. An isomer is a molecule that has the same general formula but different structural arrangements. For example, if I have a general formula of C4H10, so I can get what we call butane from this molecule, so which is CH3, CH2, CH2, CH3. Then I can branch off one of these carbons and I put it on top here. Then it becomes CH3, something like this. I still have the same 4 carbons and 10 hydrogens, but I've branched this to get another compound. So this is called isopropane, propane O3 methyl, O2 methyl propane, and this is butane. So butane and isopropane are isomers. So we should also see isomers in these structures, especially with the carbohydrates. An aldehyde and a ketone are isomers. So we've seen what we call the functional group. We've said the functional group is a group of atoms that take part in a chemical reaction. Then also, lastly, hydrolysis and dehydration reactions. So to elaborate more on this last objective, so hydrolysis, hydro means water, lysis means to break. So you're breaking something using water. For example, if I have coffee flakes and I pour hot water in them, I'm going to make a cup of coffee. So therefore, I've broken down the coffee crystals they've dissolved into water. So I've hydrolyzed them. Whereas dehydration is when I remove out the water from the coffee and I remain with only the flakes. So that's called that's what we call dehydration. So these two processes occur in our bodies now over and over in a given period of time. So when I eat a meal that has proteins, my body is going to break down these proteins into amino acids. So these amino acids are the monomers. This is the polymer. So when I break down the proteins into amino acids, I'm hydrolyzing. Hydrolysis, breaking down the big into small. So this is hydrolysis. So when I have a bunch of amino acids and I join them together, I'll form what we call a protein. So that is dehydration. Usually when you're forming a polymer or a macromolecule, you remove water. So this involves loss of water. You lose water to join these amino acids together to form a protein. Whereas I use water to break down the protein to form amino acids. So basically that's it for hydrolysis and dehydration. We shall look at more when we discuss the enzymes that are involved in these processes. So thank you very much for tuning in. See you next time.